Hey everyone, welcome to Singularity Computers Client Build 14 Part 4. So this is the final part of the build log. I'm going to start this video by draining both of the water cooling loops, and then I'm going to fill them with a new set of coolant colors. I talked about this in the last part of the build log. I'm then going to move on to completing the build. I still need to complete, install and manage the rest of the custom wiring, and I also need to install the lighting. After that, we'll take a good look around the finished product and finally move on to the test results. Now, in the last video, I mentioned that the client wanted me to try two different sets of coolant colors in this build. Often I will recommend a number of different coolant colors for my builds because there's often a number of different options that are actually going to suit the build. And it can be a difficult decision, and in this case the client wanted to actually see what the different coolants look like to be able to make a proper decision. I know a lot of you really liked the first set of coolant colors, the Mayhem's X1 UV green and Mayhem's X1 clear UV blue. And I think they worked well in this build, and I always like to use UV coolants whenever I can. They can really look amazing, mainly with some good UV lighting. And it's been a long time since I've used UV green, and it just seems to give a better UV effect than any other UV coolant. But I do think that coolant colors that are matched with the color scheme of this build are going to work better for the aesthetics of this build. Now, I almost always show the process of filling my loops, but I almost never show the process of draining a loop. And I'm going to be draining both of these loops, obviously, and you can see how easy the process actually is with a good drainage system. I mean, it's just a matter of connecting up the drainage system, removing the cap from the top, and opening up the valve. Now, I get a lot of questions about drainage systems, and I have talked about them a few times previously, but I thought I'd take this opportunity to talk about them again in detail. People ask me what fittings do I use in my drainage systems, where to place a drainage system, and a lot of other questions. Now, there is a number of good fittings out there for drainage systems, and I think the first thing you need to really think about is how important actually is a drainage system. If you consider that you're probably only going to use it once in the lifetime of your water cooling loop to drain it, to then dismantle it and upgrade it, then why should you be putting so much importance on it and building something complicated in full view that is ugly, that's going to be there for the entire lifetime of the build and the loop? You're better off this is something I used to do back in the old days. I just used to design a part of my loop so that I could easily undo a section of tube, bring that section of tube outside of the case down low, and then drain the entire loop into a large container. It wasn't until I started getting a lot of client requests to install drainage systems that are easy to use and easy to access that you started to see all of the dedicated drainage systems that I now install in my builds. And the fittings that I personally like to use, as most of you will know, is in particular the Bits Power mini valve. And I've used two of those here, one for each loop. Now, the valve comes with female fittings on both sides, so you need to connect to it with male fitting, obviously. And what I've done here, I've used a 90-degree triple rotary fitting which has male fittings on both sides, so it just means I can reduce the amount of fittings. Either that, or you need to use a male to male fitting or a D-plug. There is just so many Bits Power fittings out there that you can use. And what I recommend for people who are confused about which Bits Power fittings to purchase is just to take a look at all of the different diagrams out there of the Bits Power fittings. Wherever you're purchasing them from, there is diagrams. Take a look at the photos and the diagrams of the fittings and compare them to where those particular fittings are used in my builds, in other builds, and that's how you can learn where to use certain fittings. But I almost always go through all of the fittings I use anyway. So the next thing is the placement of the drainage system, and the only rule here is to install it as low as you possibly can. And you can see that I've stuck to that rule nicely for the CPU, motherboard and memory loop. It is literally at the lowest point, but for the graphics card loop, the radiator is down below. And I really should have installed it down on the radiator in the bottom compartment. The reason I've installed it here is obviously because I wanted to make a feature out of the drainage systems and I wanted them to match. But even if you don't install the drainage system at the lowest point, often you can't. You might have a great place to install your drainage system, but it's not at the lowest point. So you can still go ahead and install it there, because you're never going to get all of the coolant out of your loop anyway, no matter how good your drainage system is. So it ends up, what you need to do is flush the loop, continue diluting it, emptying it, and I had to do that 3 to 5 times for both of these loops before they started to become diluted enough where I decided to change the coolant. But I didn't have to completely empty these loops or completely dilute them out, because for the green loop I was putting green coolant back into it anyway. For the black loop, I was putting black coolant into a loop which had clear coolant in it. So, I didn't really have to fully empty them out and fully clean them out. And because I'm using coolant concentrates, and this is another little trick that you can do, if you can't completely empty your loop and you're using coolant concentrates, you can just calculate approximately how much fluid, distilled water is what it should be. That's what I use to flush both of these loops. Calculate how much fluid is still in the loop and account for that when mixing up your coolant concentrate. So what I did was just put more concentrated coolant back into the loop to allow for the amount of distilled water that was still in the loops. Really, the only way you're going to be able to completely drain a loop is by dismantling it and then draining out each section bit by bit. And usually what I do, as I'm dismantling a loop, I drain the different sections into small containers, or if it's only a few drops, I will drain it onto a paper towel or something similar. So both of the loops are now full. So you can now see what the build looks like with matching coolant. So the entire color scheme is now matched, and personally I do like this a lot better. It just suits this particular aesthetics of this build a lot more. Now through the camera, the green looks very different to the color of the custom paint. It looks a lot lighter, more vibrant. It's a brighter green, but in real life it is actually an almost perfect match to the color of the custom paint. The camera seems to be picking up some of the UV light or something. The coolant, I ended up using 4 different dyes: a blue dye, emerald green, laser green, and also UV green. So there is a fair bit of UV green in the green coolant, so it is still going to be UV reactive. I'm really impressed with the black coolant. Last time I used Mayhem's pastel black coolant, it was more of a gray. Mayhem's has obviously certainly sorted out this problem, because this coolant is just a perfect midnight black now. The system is now complete, and it's now time for a good look around at the finished product. Now normally I cover all of the fittings I use in detail. I cover each individual fitting, but it doesn't really seem to be helping. I still get a massive amount of questions about fittings, so I'm only going to do this occasionally from now on. It seems the people asking questions about fittings are missing the part of my videos where I talk about them. Now looking at the completed custom wiring. So you can see the 8-pin EPS and 4-pin ATX. You can see I've used ModSmart cable clips, and I almost always use these in my builds. Now these only go up to 4 wires, so I like to use these on the smaller cables, and the reason I prefer these over anything else is because they're enclosed. They clip around the entire cable. They're also nice and clean, they blend in, and there's a few different colors to choose from also. Now you can see there's a 3-pin fan cable up here that goes to the lighting and connects to a 3-pin fan header on the motherboard. We'll take a look at the lighting shortly. So the ModSmart cable clips, they only go up to 4 wires. So for the 24-pin cable, I prefer to use E22 cable combs. And I mean, just take a look at the 24-pin cable, how clean it is. Without the E22 cable comb, this cable would have been a mess. Because of the terrible pinouts of just about all power supplies, there's really nothing you can do about it except properly manage the cables. And E22 cable combs have now been released in black acrylic, which you'll certainly see me using from now on. So there is 2 3-pin fan cables connected near the 24-pin cable. They're the RPM readouts from the pumps, and I always connect them to the motherboard so that the RPMs of the pumps can be read in certain software. And the software I like to use is AIDA64. And I might do a video on AIDA64 at some point because it is excellent for monitoring water cooling systems, benchmarking, stability testing. It's a great program. So you can see the front panel cables, how clean they are using this technique, which I have talked about previously. I've used 2 USB connectors and I'm holding them together with heat shrink, so it just looks like one connector. It's very clean compared to all of those horrible looking tiny individual connectors that you normally have. I'm really happy with the way the PCI Express cables have worked out, and that's mostly thanks to the ModSmart cable clips, and you can see I've used quite a few of those here. Now, something you can do, in the beginning it's often difficult to get the cables to sit in position, to train them. It's actually a lot easier with custom cables that have been properly made, but once you get them to sit in position and you leave them for a while, probably a couple of days, often you can go back and remove a lot of the cable management components that you used. So probably down the track, all of these ModSmart cable clips can be removed. The reason I use them a little bit excessively is because all of my systems need to be shipped a long way, most of the time internationally, and so I don't want anything to move around. Now, the thermal design of this build is very basic, and the STH10 allows for an excellent thermal design and quite a number of different options. But you can see here, all I've done, I've kept the cooling compartments completely separate from the main components and the main compartment. And this is obviously a good thing because it means there's no hot air from radiators being drawn into the main compartment and heating up the main components. All of the hot air from the radiators is so that cold air is being drawn across from this side, and then the hot air is being blown out of the back, and the power supplies are drawing the air from the radiators and then out through the back of the case also. And some people might think that this is going to affect the power supplies, but the air coming through the radiators really doesn't get that hot. It only gets hot when you don't have enough radiator capacity. So it doesn't really affect the power supplies much at all. Now, I could have put a fan on the back panel, drawing air into the main compartment, but considering everything is water cooled, I didn't really think it was necessary, and it just means another entry point for dust. And even with the best dust filters, you still end up with dust in the case. So that is another great thing about this thermal design. It means that the only dust that is going into this build will end up on the radiators. Nothing will end up in the main compartment because there's no airflow through the main compartment. So it means a lot less dust cleaning of all of the main components. Now for a look around the back of the build. I'm really happy with the way the custom wiring and cable management has turned out back here. You can see that the 24-pin cable is a bit messy, but seriously, that cable is obviously being completely customized, and it is as good as it can possibly look. We have cleaned it up as much as possible. We've removed crossovers by changing the actual pinout, and we've done soldering. I just really wish that manufacturers would sort out their pinouts so that they're direct. It would make custom wiring a lot easier, and it would make the cables a lot cleaner. They would look a whole lot better, and I just don't see what's in the way of the manufacturers doing this. Now, something we had a bit of trouble with was wiring up both of these power supplies so that they start at the same time, synchronizing them. And I know some of you are going to be thinking it's easy, it's just a matter of connecting the two correct wires, which is usually the green or gray wire and also an earth. And with all of the other power supplies I've used dual power supplies with, that was the case. But with these power supplies, it was different. And this is something to consider with Seasonic power supplies, because I did some research and I've seen that a lot of other people have had this problem, and actually no one ended up figuring it out that I could find. Now, you can just use a relay or some PCB like the Add2 PCB, which is great, but I obviously wanted to avoid using something I didn't have to, having the extra component, the mess and the bulk. And we did even make up our own relay, which we had working perfectly. But in the end, I figured out that we needed to run one extra earth, which makes absolutely no sense, but an extra earth between the two power supplies, and also the earths had to be specific earths. So specific pins from one power supply to the other. Otherwise, it would not work. So in the end, it just means there's 3 wires running from one power supply to the other instead of 2. So you can see down here those wires, and it looks like there's 2 wires, but one of them, there's actually 2 wires sleeved together, and they go into pins that are right next to each other. So the way I've split up the components from the Seasonic 1000 watt Platinum, which is down the bottom, I'm running the graphics cards, pumps, the lower fans, and also the SSDs. Then from the top power supply, which is the 860 watt Platinum, I'm running the 24-pin, 8-pin EPS, 4-pin ATX, and the top fans. The system is now up and running, and I've installed all of the panels onto the case. The request for the lighting for this build was to install a small amount of subtle lighting. Now obviously with the previous coolant colors, I was going to go with UV lighting, but with these coolant colors I've decided on white lighting. So I've installed a single white LED strip at the top of the main compartment. The lighting I've used in this build is from Darkside, and I'll put a link in the video description to where you can pick this up from. As I've mentioned previously, I am really impressed with every aspect of this lighting. It is by far the best lighting I've ever used, and just everything about it is, exactly what I would do myself if I design lighting. And, for example, I like to connect my lighting to 3-pin fan headers, whether it's directly to the motherboard or to a fan splitter, and this lighting comes with 3-pin fan connectors. That's actually what I've done in this build. I've connected the lighting directly to the motherboard, and there's a number of benefits that come from doing this. It means you need less wiring length and mess because you don't need to go right out to the back of the case. And I mean, as long as you can hide the wiring nicely, depending which fan header you connect it to, it works out well. But another benefit is, in this build, the lighting is still a bit too bright, and I've decided to use the fan speed control settings in the BIOS to adjust the brightness of the lighting. I'm going to set it down to about 80%, and you can even set it up to be dynamic based on temperature. It just depends on how good the fan speed controls are in your motherboard BIOS. Now moving on to the test results. Now the client requested an overclock for this system, so I took the CPU to 4.5 GHz, 1.4 volts. And that might not sound like a lot, but for the 4930K, at least all of the 4930Ks I've overclocked so far, I have had a lot of trouble with. And it seems that anywhere beyond 4.6 GHz, and you just need to increase the voltages to ridiculous amounts. So obviously for a client build, I'm not going to take extreme risks. I need a 24/7 guaranteed stable overclock, so I can't take it too far. The memory I took to its XMP profile of 1866 MHz, 910, 927, 1.5 volts. The graphics cards, I found that I couldn't overclock the memory at all. Even small overclocks, and I started getting artifacting and instability, which I was surprised with. But usually with multiple cards, the more cards you have, the worse the overclocks get, and it seems to be the memory that often suffers. The core, I took 100 megahertz over. I increased the power limit to the maximum, which I believe was 135%, and I also increased the core voltage by 30 increments. So I'm going to start with the temperature results. Now, for all of my temperature testing, I mathematically adjust my ambient temperature to 20 degrees Celsius. All of my results are in degrees Celsius, and they're an average of the cores. For the idle test, I cold boot the system and let it idle for 30 minutes. For the load test, I run the 8064 stability test for 30 minutes. Starting with the CPU, at stock clocks at idle 30.5 degrees, overclocked at idle 33 degrees, stock clocks at load 53 degrees, overclocked at load 64 degrees. Moving on to the GPUs, at stock clocks at idle 22 degrees, overclocked at idle 23 degrees, stock clocks at load 37 degrees, overclocked at load 41 degrees. Now for the motherboard and PCH, when the system was overclocked at full load, I didn't see the motherboard go over 38 degrees, and I didn't see the PCH go over 35 degrees. Now, I didn't actually get any noise output or power consumption results for this system, but I can tell you that there are no components in this build rated at over 20 decibels, except for the pumps, the Swiftech MCP655s, which are rated at, I believe, up to 35 decibels, but I find that they are never this loud, mainly once you install pump mods. The Bits Power pump mod, the cover that goes over the back of the pump, by the time you install all of that, these pumps run very quiet. I find that they're even quieter than the Swiftech MCP35X and all of the DDCs. So, in my opinion, this system runs at less than 20 decibels. For the power consumption, also considering the overclock, I would say it runs at a maximum of around 1000 watts, maybe up to 1100 with the overclock. Now for the performance results, which I've included in screenshots. There is stock clock results, overclock results, and also results for the RAID 0 Samsung 840 Pro SSDs. So you would have noticed that for some of the benchmarks, the overclocks meant almost no increase in performance, whereas for other benchmarks, the overclocks meant fairly decent increases. But definitely the limiting factor here is the CPU and CPU overclock. It's now time for me to conclude this build log. As always, I've had a lot of fun building this system, and I'm really happy with the way it's turned out. In particular, the water cooling loops in this build I'm really happy with, mainly the graphics card loop. When I was overclocking and testing the graphics cards, at one point I had them overclocked even further than the overclock I ended up deciding on, and I had them at full load, and still they were less than 10 degrees above ambient, and I was actually starting to question the software I was using to monitor the graphics card temperatures. And this just comes down to the larger diameter tube, the thermals in this build, and the large radiator capacity. Also the fact that I'm using a black ice radiator. I always get better results when I use black ice radiators. I've been using them for a long time, since long before I started my channel, And actually I still have a couple of black ice radiators from long before I started my channel, and they're still in perfect working order. Now coming up, I have something massive to announce on my channel, and it's going to be soon, and you're also going to be seeing it soon. It's something I've been working towards for a long time, and also people have been asking for it for a long time, so it's very exciting. So that sums up this video. Thanks for watching. Please subscribe, like, and favorite if you want to see more.